Okay, first things first. What do we need to get points on the problem? So here are the 5 things you need. You need a picture. You need knowns and unknowns. You need an equation. You need to solve. And you need an answer. Problems are generally worth 5 points. It's not 1 point for each thing. It's like a half point for the answer, a half point for the picture, 2 points for the solving. So like they're worth not exactly the same number of points, but they do work through each other in the same fashion. So those are the 5 things that you need. So let's look at example 1, solving for horizontal motion. So what's the acceleration of a moose that goes from 13 meters per second to rest in 6 seconds? So first things first, I'm going to draw a picture. So I'm going to draw my moose. It's very, very long and stocky moose. There we go. Thank you. That's a moose if ever I've seen one. Moose is on the loose. Okay, so it tells me a few things that I can put in my picture here. So the first thing it tells me is that it goes from 13 meters per second to rest. So I'm going to start by writing VI for my starting velocity, and I'm writing 13 meters per second. Then the problem says that the moose stops. So that means V final is 0. Okay, so I got my picture drawn. I got the object and what it's doing. Now that I get the picture, I need knowns and unknowns. Well, I already got 2 of them. I already wrote down VI and VF, so I don't need to rewrite them again. I already got them once. Okay. So now that I got VI and VF, I just need to write down anything else that I'm given. It says, what is the acceleration? So we're solving for A. And it says that it does this in 10 seconds. Sorry, 6 seconds. Okay, third step, figure out an equation. So at the bottom of the page, you've got your list of equations. So you got V equals d over t. This is the velocity equation. You got A equals delta V over t. That's the acceleration equation. In case you've forgotten, delta V means change in. In this case, change in velocity, which is final minus initial. So if you forgot that, that's what that is. Okay, then these are the 3 kinematic equations. And if you had me or Mr. Rohrback, you've probably heard the goofy names that I gave them. If you had Mr. Haiduku, you're going to shake your head and say, what's going on here? But just bear with me. So I gave each of these names to make it easier to identify which one you're using. So the first one is Old Faithful because it's the easiest and we use it the most often. The second one is Big Chalupa because it's the largest and spiciest one. Yeah, because it ain't got no time in it. You did learn things from last year, Tony. All right. So, for my problem, I need to figure out what equation am I using. So I'm looking at what I have, VI, AT, VF. And I'm saying, okay, V equals D over T. So that doesn't have, so that's not going to work because it has D in it. We don't know anything about D. Also, this is the constant velocity equation. So it only works if your velocity is constant, which ours is not. Okay, so I'm going to look at the acceleration equation. I'm solving for A, which I am in my problem. Delta V is final minus initial. I know those. And it's divided by T time. So since that one works, I'm going to use it. So A equals delta V over T. And now I'm ready to solve. Delta V is final minus initial. So this is 0 minus 13 over 6, which is negative 2.17. And there's your answer. Now you might be saying to yourself, but Mr. B, I used Old Faithful, and I got the same answer. Yeah, and you're more than welcome to it. Okay? If you used a different equation but got the same answer, I'm all in. All in on it. Okay? Because frequently there is more than one equation you can use. Okay? So that takes care of example 1. There's my setup, there's my solving, there's my equation, my picture, and my answer. Okay? Any questions on that one? Yes, sir, I do.
Could you have just let it as a fraction?
Like negative 13. Like, I would simplify it, but like negative 2 and 1/6. I'm okay with that. Yeah. Yeah, because if you simplify the fraction down, I can usually figure out if it's the same answer as mine. Okay. All right, I'm going to give you some time to work on the front page. So the front page is 1 through 4. And I'm going to do 2 other quick things. I'm going to make the problems a little easier. I'm not going to make you convert right now. Let's just focus on one thing at a time. So 35 kilometers is 35,000 meters, so go ahead and change that. And 550 centimeters is 5.5 meters. So make those 2 changes, and then you should be good to go on the rest.
What was the
First change is 35 kilometers into 35,000 meters. Okay, I'm going to give you some time to work. I'm going to come around and see what questions you have. We'll go through what there is, and then we'll move on from there. I'll do example 2 on the back side, and I'll give you some time to work here in the first go-around. test. Does anyone need a calculator? Again, I don't want you using your phone. So if you need a calculator, anyone need a calculator? Yeah. Yeah, so they all have time, right? So it's looking at the other two things, and the other two things are velocity and distance, and that's it, right? So it doesn't say anything about changing, right? It just says you're going 35. So as soon as I see that, I'm thinking of this pattern, because that's your constant velocity. Same. Almost the whole week done. Almost made it. Yeah, let's do that now. And the reason is I want you to get what happened because I definitely need them on the vertical motion. Because on the vertical motion, I gotta see what direction it's going in. I gotta see if it's positive or negative. So I just want you to kind of get that. And again, it doesn't have to be complicated. I'm going to show you before and after. Yes, sir. No. So this one says it's just going 35. It doesn't say speed up. It doesn't say speed down. It just says 35. So this needs to be yeah. No. So to multiply both sides by t to get t by itself over here, then you would divide both sides. Any questions here so far? Yeah. So you could start by finding the time. So I would no. And the reason why the reason you can't use this one is because you don't know time. It doesn't say it, and it wants to know how far you go. So you would have t you don't know and t you don't know. So yes. Oh, you come to velocity. Even though t is but yes. No. Oh, no, it's weird.
This is my turn. All of my pictures.
jump to one more thing, and then I'll give you rest of the period to work. For next class, you should have the front page done. Okay, but try to get as far as you can. Let's jump to the back page and do example 2.